Hey, good morning and welcome back. We're taking a look at lesson 11.1, and lesson 11.1 involves parallel lines that are cut by a transversal. We all probably have a good idea of what parallel lines means. Parallel lines means they won't ever intersect. So if I, for example, call this line A and this one down here line B, these lines will go on forever and they'll have the same slope. There will always be the same amount of distance between them. And if we cut them by a transversal is a line that cuts across two other lines. And right here you can see this transversal cuts across line A and line B. And we've got some angle vocabulary we need to deal with. First of all, there's going to be 8 angles total that are created. You can see these two up here, these are angles. These two down here, there's 2 more, and then there's the last 2, so there's 8 total. 4 of these are interior angles. The interior angles are in between the 2 parallel lines. So those angles right there that I just scribbled in, those are the interior angles. And out here, these angles on the outside of the drawing are called exterior angles. So this right here, we might say line A is parallel to line B, and it's cut by a transversal. Now, when we have lines that are cut by a transversal, we create 4 different types of angles. The first types are called corresponding angles. Corresponding angles, like these 2 that are highlighted here, are on the same side of the transversal, and they're on the same side of the line. So for example, this angle down here is on the top of this line, and this angle right here is on the top of this line, and they're both on the right side of the transversal. Another example of corresponding angles might be this angle here and this angle here, because they're both on the bottom of their line. And you can see that they're essentially in the same place on their own parallel line. So they correspond to each other. Second type of angles are alternate interior angles. Now, we talked on the last slide about the difference between interior and exterior. And you can see here that this angle down here is on the left side of the transversal, and this angle up here is on the right side. So they're on opposite sides of the transversal, and they're interior. Let's take a look at alternate exterior, kind of like interior, but of course they're on the outside. You can see that this angle right here and this angle right here on the outside, they're on opposite sides of the transversal. Those are called alternate exterior angles. This is another pair of alternate exterior angles. The last type that we need to talk about are same side interior angles. So they're on the same side of the transversal, and they're on the inside or interior of the 2 parallel lines. Now, there are 4 big ideas that you have to know about parallel lines. The first ones, and if you want to write symbols on your notes, corresponding angles are congruent. Alternate interior angles, those things are also congruent. And so are alternate exterior angles. Those are congruent. So for example, the number of degrees in this angle would be the same as the number of degrees here. The number of degrees in angle X would be the same as the value down here. They would have the same number of degrees. And the last thing you need to know, and this is the only one that's different, same side interior angles, these things don't look the same at all. This is an acute angle. This right here is an obtuse. It's more than 90 degrees. Same side interior angles add up to 180 degrees, which makes them supplementary. So you might want to underline that word on our notes, because we're going to see that as we go forward. So on this example, we're going to go ahead and name 2 pairs of each type. And I'm going to name a pair of a couple of these just to give you an example. If I want to name a pair of corresponding angles, remember they're like in the same position on a different line. So for example, angle 1 is on the top left, and so down here I want to find the one that's on the top left, and if you can see the one that's on the top left, you see it right there, it's angle 5. So angle 1 and angle 5, and this is how we're going to write it. This is one pair, and you can find another pair. There are 3 more pairs of corresponding angles. If I jump over to this one, same side interior angles, there's only 2 pair of these. They're on the interior of the drawing, so they're in here, and they're on the same side. So for example, angle 6 is on the same side as angle 4. So angle 6 and angle 4 are one pair of same side interior angles. And remember, those two will add up to 180 degrees. I'll let you go ahead and name 2 of these and 2 of the alternate exterior angles, and go ahead and add another pair up here of your own. Now to wrap this lesson up, we need to go find some angles on the drawing if I know that these lines are parallel. And the first thing you need to do is you need to identify what the relationship is. So I can see that this angle right here is 78 degrees, and I'm looking for angle 1 because they want to know what's the measure of angle 1. By the way, we might write the measure of angle 1 like this, a little m, and then an angle symbol and a 1. That would answer the question of what's the measure of angle 1? Well, I can see that they're both on the inside of the drawing and they're on the same side of the transversal. And if you go look at your pictures, you'll recognize these are same side interior angles. And that means they add up to 180 degrees. So angle 1, the measure of angle 1 plus 78 degrees equals 180, because those two are supplementary. And if I want to find the measure of angle 1, I'm just going to subtract 78 degrees from 180 degrees, and that's going to give me the measure of angle 1, which is 102 degrees. Now if I take a look at this drawing here, I can actually find the measure of every other angle on this drawing if I only know one angle. Because you see, this is 154 degrees, and it's in a corresponding position. It's on the top, on the right side of the transversal, as this one right here. So angle 5, the measure of angle 5 is also 154. Now, angle 5, I put the degree symbol, angle 5 is alternate interior to angle 2, because they're on the inside of the drawing and they're on opposite sides of the transversal. That makes angle 2 also, the measure of angle 2 is also 154 degrees. And there's one more corresponding angle to angle 2. What's in the same place down here as angle 2? Well, if you look at the bottom left, we're looking at the bottom left, it's angle 6. So the measure of angle 6 is also 154 degrees. When you have parallel lines and they make 8 angles, 4 of them are going to be the same. And all 4 of the other angles are going to have the same number of degrees. So if I go by the fact that same side interior angles are supplementary, if I want to figure out what angle 3 is, all I have to do is take away 154 degrees. And 180 minus 154 leaves us with 26 degrees, which tells me that all of these other angles are going to be 26 degrees. So you can see that once you know one angle, when you have parallel lines, you can find all the other 7 angles that are created. Now here's a situation where I don't know any of the angles, but I have expressions. I have an algebraic expression for this one, and I have an algebraic expression for this angle up here. You have to identify what kinds of angles these are. Well, they're both on the right side of the transversal, and they're both on the inside. So that makes these angles same side interior angles. And same side interior angles add up to 180 degrees. So I'm going to write an equation that says this angle here plus this angle here add up to 180. So it's going to look like 2x plus 3x plus 20. All that together makes 180 degrees. Just combine our like terms. 2x plus 3x is 5x plus 20. And we're just going to go ahead and take a moment and solve the equation. We're going to find x. A lot of times we're just asked to find x. So here we get 5x equals 160. And when we divide by 5, we're going to get x equals 32. Now, if x equals 32, I can plug that back in, substitute it in. This says 2x. So this angle right here is 2 times 32, which is 64 degrees. And this angle here is 3x plus 20. Well, if I multiply 32 by 3, that's 96. Plus 20 is 116 degrees. And remember that they both have to add up to 180 degrees. 64 plus 116 gives me 180. So we found x, and we found both the angles. In fact, if this is 64, so is this one, so is this one, and so is this one. And then the other 4 remaining obtuse angles are all 116 degrees. Here's another situation, but this time I don't have same side interior angles, which means these two don't add up to 180. These are both corresponding angles. They're on the top left of their parallel line. Corresponding angles are congruent, which means these two angles here are equal. And we need to write an equation that says that. 12x plus 3 equals 11x plus 9. And then we just go about solving the equation to find x. We're going to move the smallest number of x's first. We'll take away the x, and we'll get 1x plus 3 equals 9. And we're going to take away 3. We'll get x equals 6. And that's it. Last problem, you can see too, these are both on the top right-hand side. That angle and that angle right there are both on the top. They're corresponding angles. Corresponding angles are congruent. So we're going to write another equation that says 17x minus 4 equals 12 plus 15x. And we will just go ahead and solve this equation. We'll move the smallest x's first. Take away 15x on both sides. And that'll give us 2x minus 4 equals 12. We'll add 4, and then we'll divide by 2, and we'll get x equals 8. So 2x is 16, and there you go. So it's really important that we start with an equation that accurately represents the situation. If they're same side interior angles, let's show that they add up to 180. But if these are like corresponding or alternate interior or alternate exterior, we definitely want to write an equation that says, like this, that they're equal.